documentation of startup for Fontana Lift Station, which includes and primarily is focused on verifying pump flows for the station. You see a layout here showing how we're going to recirculate potable water from the wet well back into the wet well from the pumps. Flow criteria is listed here, showing low range and high range, what should be expected in GPM performance of each of the pumps. This is a schematic of the mechanical aspects of it, and here's a layout as seen, photographs, except for we have a flow meter instead of a flow switch. This is the form we use to record all the data on the flow test for each of the pumps from 30 Hertz to 60 Hertz. We're looking at setting up the Modbus system here, where we have automatic communication from the PLC to the VFDs, and communication here is by way of Modbus, as I said, but it's ultimately ends up in SCADA and it's controlled remotely. This is an Allen Bradley, a PLC system.
Come over here.
And part of our documentation included the automatic startup of backup generation.
Starting?
We had to use a portable generator because we couldn't get a permit for the permanent generator. And this involved extra time, extra work. We had to set up the portable generator so that it would receive a start signal and controls from the transfer switches in interior here. So we had to work through a number of different issues here.
Alright, now it's saying 30 minutes to bypass. You want to get that there?
Yeah.
We don't want to wait 30 minutes to transfer, so I'm going to hit bypass. Alright. And then it'll transfer in 3, 2, 1, transfer. And transfer. Oh, there's another this bypass here, right now we're on normal power with generator power available. Okay. What I can do is hit bypass, that'll shut off the call for the generator will go off. Or it'll time out. We want to bypass? Yes. Generator just went off.
Okay, looks good.
That was for 61.
This is the seal water system. It's used to make sure that the bearings and the seals stay well lubricated on each of the 4 vertical turbine pumps. Our chief foreman here, Fred Lichtenstern, figured out a way they could save all kinds of water. His original design called for the water just to be expelled. Here we have verification of each of the steps and commissioning, in this case the PLC. Here's the actual flow output.
Fulfill the C.
35 Hertz, 35 Hertz. And we're pumping what, 6,600 gallons per minute. Okay, and these are still at 30 Hertz. 30 Hertz for each of these. So I'll just let it run at that.
Yeah.
And now it's running at 67, almost 6,700 or so.
66.
Okay.
I mean 67.
All right.
Starting with each of the pumps, we follow the flow test report in order to verify flows. So what we're looking at here is the result of looking at the 2 lower horsepower pumps. And we repeated each of the processes until we'd filled out the entire report. It showed that through 30 through 60 hertz for each of the pumps, it produced the flow in gallons per minute that was expected, as specified.
Right. 5,500. Or 6,200.
A critical part of the commissioning is the training. In this case, we're training on the VFDs and how to use the keypad to control the operation for the VFDs, either in manual or allow it to be used in automatic. Included in the on-site training is use of PowerPoint presentation, multimedia, PC-driven applications. This particular room is pretty small, but there weren't that many operators, so it worked out just as well. These sessions last from anywhere from a half hour to 1 hour, and meanwhile we have other crafts people and technicians working on particular things while this goes on. So it's a pretty active area during this process.
Notice that when I select the basic and then I hit the enter key again.
A critical part of the commissioning and startup is verification of the vibration of the pumps. We have Rush Allen from Rush Allen Engineering here to do a complete breakdown and analysis of all 4 pumps. And he predicts using this equipment here where what frequency the pumps vibrate the most at, what hertz, and then through this process you can do selectively omitting certain frequencies in a VFD drive so that the pump is guaranteed to operate well within its parameters. As it turns out, these pumps didn't have any attenuation problems. They were well within bounds and the specified criteria, even though Rush had to present his reports a number of times to the engineering inspectors. This is the slide gate. We had to also show that the slide gate would hold back the effluent. Do we need to isolate the lift station? It's allowing about 2 gallons per minute leaking.
Stop.
The same, maybe.
Alright, this is definitely less than
Maybe I think you want more than the same.
1.6 gallons. So the test passed.
Patient ATS.
Alright.
Yeah, we get right here, straight up. Okay, kill the normal power. Alright. 5 seconds. Is it starting?
Yep.
Yeah.
Starting, okay, it's powering up. We got voltage available. 5 seconds. 1, 4, 2, 1. Transfer. There you go.
Seamless.
This is my last project with Brudico Engineering due to economic conditions. I'm now with Cube Engineering providing sales and service for this very same equipment. However, we have a line card that indicates that it's not the same manufacturers in some cases. Look forward to assisting you in your needs, full startup and commissioning support, as well as sales, competitive pricing, high reliability. Thank you for your time.
7,185 or 80 gallons.